bit about what we're going to talk about today. So we're going to talk a little bit about designing an Android application, architecting an application. So basically, I'm going to talk about activities and UI, just to start with things that are tangible that you can easily relate to. We're going to talk about intents, action bar. We're going to talk about services, things that happen in the background. We're going to talk about content providers. This is basically your data. We're going to talk about lists and adapters, broadcast receivers. I'll explain what that is. And finally, we're going to wrap up with something called an app widget, which is basically one of those little things you can see on a home screen and you can touch it and it opens up something. So before we jump into that, anybody wrote an Android app before? I talked to a couple of people. Okay, so a handful of you have. And was that a native app or was it an HTML, CSS, JavaScript type app? Native. Okay. Anybody else native? How many native apps? A couple of you. Perfect. Cool. Well, hopefully for you it's another nice little overview of things that you may or may already know. So we're going to talk about, I'm going to be using an application as an example application in this presentation. We call it Yamba. It stands for Yet Another Microblogging App. Because we can't call it Twitter, right? It's a trademark. But basically what it is it's a Twitter-like application. So I'll be using this application to basically explain how things work in Android. This proved to be a very good sort of demo app over the years, and that's what my book is based on, and that's what we do all the training based on, and so on. So I'll quickly show you what that app looks like. So basically, it's a very simple learning app. I can click on I have a bunch of tweets from people, statuses, right? So this is an emulator I'm using, so it may not be the smoothest ever because it's emulated in my computer. But you can basically click on a little item and it just pops it up. You can go back. You can change. You can, for example, update the status. You can say, hello from building 10. You can click on update. That is now actually trying to go online and post. I don't know if my network connection is going to work. It says it did. I can go back to that app. I can click on refresh, and there's a background service that's pulling this data. And I think I just crashed it. But basically, this app is using a backend service called Yamba, which is running at yamba.maracana.com. It's basically our little controlled environment because Twitter wouldn't let us do what we do. But if I click on refresh here, and keep in mind so that's our post right there, right? So that's basically the little application that I'm going to use just as an example, a way to make things a little more tangible. So moving on with that, so what we're going to be talking about is the Yamba app and components in it. So basically, Yamba is what's good about it is that it's very comprehensive. So it shows you how all the main components work. So it doesn't focus just on web services or just on UI. But it's got a mix of things, so that's a good thing. And we're going to do it in small increments. There are going to be 7 increments that we're going to walk through in this, in building this, architecting this application. So think of this as sort of like your generic app. Like if we're talking about web development, I'll probably walk you through building a blog site or something like that, right? So it's one of those generic learning applications. So we're going to be using this lots of pictures. So this is basically a design diagram that eventually is going to become a full screen. And just to kind of give you an idea what things are here, because it's sort of a new graphical language that I came up with because one didn't exist before. But basically, this dotted line that you're seeing sort of go around here, that is the application. That's an entire app. And we're going to be throwing components into this app. So I'm going to start with lines and circles so you can kind of understand it high level. And then we're going to possibly look at a little bit of a code, but I don't want to go too much into a code because code is easy to figure out once you understand the concepts, and we only have so much time. So basically what we're going to be doing first is we're going to create this little screen. It says status activity for those of you in the back row, but basically it's going to let us update our status, just like I did when I said hello from building 10, right? So it's that screen. In the context of that, we're going to talk about UI. So basically, this is that application that you just saw earlier. I'm now showing it in sort of more of a tablet view, if you will. So it's more of a landscape view versus a portrait, so that's why you're seeing more information that you did initially. I'm going to actually rerun that application here so that we have it actually running, and should be showing up on the screen in a little while. So that's our app again, and what I'm going to do is I'm going to rotate the screen. So that's basically the view that we're looking at now, and it's kind of hard to, there you go, so you can kind of see it, right? So that's the app. So basically, what you're seeing on the screen is what we call an activity. It's one of the first building blocks, right? So in Android, we have about 4 main building blocks, and this is what we use as components to build just about any application, any complexity application. So activities are your UI, right? Activities are your screen. It's one activity takes an entire screen at one point in time. What's interesting about activities is that they have a pretty complex lifecycle. So basically, the system manages the lifecycle of your activity. So the system is going to, at the beginning of the day, you have your activity that's not running. User hasn't started the app, right? And you may click on, I want to start the app. And what happens next is there's a bunch of what we call callback methods getting invoked against your code. So there's something calling your code. So it's not you running your code, it's the system pinging the callback methods inside of your code. And eventually, your activity becomes visible on the screen. So it's on the screen right now interacting with the user. There can be only one activity ever in focus on the screen interacting with the user at one point in time. So this is where Android is sort of different than maybe some other systems that you have experience with. At some point, the user may say, all right, so I'm done viewing this. I want to go to another screen. So flip to another activity, another screen. And we quickly go through so-called pause state, only to usually end up in the stop state. So basically, really quickly, your activity is going to end up in this state here. So basically, you can have many, many activities in so-called stop state. And what that really means is that they're still in memory, they're still taking your resources, they're just not on the screen visible and not in focus interacting with the user. So it's basically kind of like a cache, right? The point of this mechanism is that it's very likely that you're going to want to come back to the running state. So it's just human nature, we come back to the same screens that we used before. And these steps here, going from starting to running, basically a cold start, is very expensive. It takes a lot of resources to get started. It can take seconds, right? Because you need to launch a new virtual machine, you need to create a new Linux process, you need to load a bunch of Java classes. There's a lot of stuff that goes on at that point in time. This tends to be much cheaper, much more efficient. So that's why the system keeps things around. And that's why in Android you do not have a quit button. I don't know if you noticed that. But the system wants to memory manage for you. Unlike when you use your Microsoft Windows and you're done with your Microsoft Word, you usually quit it, right? Because it takes a lot of resources. So what you're doing is you're memory managing the machine, right? Well, Android team thought that machines should be capable of doing their own memory management, sort of like you don't change gears on your car, or at least most of us don't. So they kind of took that approach as well when designing Android system. At some point, the system is going to have some heuristics and it's going to say, all right, time to destroy this stopped activity. It's no longer needed. It's just sitting there taking a lot of resources, and the user is unlikely to come back to it. So the system basically destroys it. So that's a little bit about the activity lifecycle. This is probably one of the most complex components that we have. I'll get back to the questions toward the end, but do jot them down. So basically, what I did is I kind of like explored what happens with an activity, in various situations, like when you start it first time. So we go through that on create, on start, on resume state. So if you remember, what we're doing is we're going through the callback methods. So we're basically running through these callbacks, which could be empty, but they could also be doing something interesting. So that's basically what happens first time you start it. When you click on a back button, what happens is one of your activities, the one that you're currently in, gets the event that says another activity is about to get started, pauses the current activity, stops the current activity. Then when we click on a back button, restarts it, starts it, and resumes it. So we pretty much go through the entire cycle to get it back on the screen. When you rotate the screen, we actually dispose of the activity and recreate it from scratch. So the rotation of the screen by default is pretty expensive. Lots of things go on to just rotate that screen that people tend to do all the time. So that's why it's a little not as responsive as it could be. That's just a default behavior. There are options to do that, to do a different behavior as well. When you press a home button, basically activity just gets paused and stopped, and it's basically sitting in that cache in the background. So that's a little bit about what goes on. And when you click on a status bar, you can restart it, start it, and resume it. So basically, you can bring it back from that paused cache state. So that's a little bit about the details. I know it's a lot of small text, so I don't want to bother you with that too much. For those of you who are familiar with code, at the end of the day, this is what code looks like, but I don't want to get you too stuck on the actual Java. But basically, what we have going on here is we have some kind of activity which is extending from a system activity, and then what we're doing is we're just overriding a bunch of methods. So that's what I mean by a callback methods. You just basically fill in the blanks. You could be doing something interesting in those blanks, or you could just be not implementing them at all. So it just really depends on at what stage of the lifecycle you want to do something. So those are the callbacks on pause, on start, on restart, on destroy, and so on and so on. There are a couple of other things that I added here, and that's mostly for processing the menus, which I'll talk about later. So the callbacks, like I said, the main ones are the lifecycle ones that get called when the activity is going through a different stage in the lifecycle. So on create, on resume, on pause, on restart, and on destroy. And that's what we just talked about, at which stage which one gets called and what you usually want to do in any of those particular stages. On create is sort of like the universally important one. If you remember on create. It's kind of like your constructor or your init method. That's where you initialize things. You're almost always going to have that one. The rest you may or may not have on a regular basis. And there are many other methods. I just kind of mentioned some of the more common ones that you already saw, but one is for creating the menu to basically load up the menu system that an app has. Once you write your Java code, what you typically need to do is you need to register it as part of your application. So this is kind of interesting. In Android, an app itself is nothing but a collection of these components, right? So an application actually doesn't really exist. It doesn't really do much, right? So it's really just a hodgepodge of activities, services, providers, and receivers. This is what I call main building blocks that we're talking about. So they're relatively loosely coupled. So basically, there's a file that specifies all the components that you have in your app, and that file is called an Android manifest file. It's sort of the main file describing your entire app. And basically, you would need to just say, hey, I have an activity, and your main activity, sort of your entry point, sort of like a home page on a website, right, would have something called an intent filter, which I'll talk about later. But most of the other activities would simply be usually a one-liners in that file. That file is usually about 1 or 2 screens in size. I actually have the Eclipse environment open up here. This is what we usually use for Android development. And if you just cared about that, but that's basically that file for Yamba. It's about 80 lines of code or so of XML. So it's not unmanageable. That was a double negative, so it's manageable. So what we're going to talk about next is the user interface. So so activity is there to hold your UI, and it's got this fancy lifecycle that it goes through to protect the memory and manage memory and all that other stuff. But ultimately, you got to build your UI. And this is where Android is sort of different than a lot of other systems that you may be familiar with. I remember in Java, we would use something called AWT or Swing to create UI. You may be experienced with HTML, CSS, those sorts of things. In Android, we actually have a combination of the two, right? So basically, there are 2 ways to do UI. You can do UI declaratively, and what that means is that you're essentially creating UI using XML. And that's a really nice way because you can use some graphical tools to help you out with that. The other approach is to do it programmatically. Basically, you write your Java, okay? So I'll give you an example. If I have a simple little screen, so let me pull up for example, that status activity that you've seen before. And sometimes Eclipse has issues with this, but we'll see if it loads up eventually. Essentially, there we go. So I have my screen. That's the screen you guys saw earlier when I typed in hello from building 10. And And so this is a very familiar environment. I could, like, for example, take some stars and drag and drop it here, that sort of stuff. So you can basically build your UI by just doing a drag and drop. But at some point, you got to say what the UI actually does. Like, what happens when you press that button update? There's going to be some kind of logic, right? So it just happens that XML is really good for building drag and drop tools, right? Think of it as sort of Dreamweaver, right? You can really quickly whip together a web page. But then what happens when you click on a submit button? So it's sort of similar. So we whip together the UI using XML and tools like that. See, ultimately, it's just a little bit of XML. It looks like an HTML page, more or less. But at some point, we got to flip over to Java and actually implement it. So the Java code that kind of relates to this would be the status activity. So it's, it's a little more code. Don't want to go too much into details. But the point is that we're mixing and matching. XML gets us there faster. And then in Java, we say what the button actually does when it's clicked. Okay? So that's sort of the approach that's sort of unique to Android and unlike many other platforms. So we start with declaring XML, inflate it into Java. Ultimately, it's all Java. And then we finish it by adding actions in Java, programming it, basically. So for those of you who are familiar with Java or most of the other UI frameworks, this is where they're all sort of similar. They're not different, they're similar. Most of them have a hierarchy that is usually something like this. So basically, you have either a container that contains components, like in Java Swing or AWT. In Android, we have the same thing, we just call it different names. So we call containers, we call them layouts. They basically are capable of containing other components. So you can have a container within a container or a layout within a layout. And then ultimately you would have a widget, like a button or a piece of text or a text area or something like that. Right? So basically, for those of you who are familiar with design patterns, this would be a composite design pattern for building a UI. So Android does a very similar sort of approach to building a UI. So at this point, we have our app. We are done with part one. And part one, all it has so far, if you remember, this is all we've built. We've built a simple little screen where you can type in something, press a button, and what it does is does a web service call and posts to some kind of Twitter service. In our case, it's yamba.maracana.com. But it's a cloud nonetheless. So it does actually make a web service call. So we cannot see what other people are saying yet. We cannot update our username and password, none of that. So what we're doing in the next iteration is we're going to build a so-called main activity, our entry point. We're going to add a menu so that you can specify what buttons you have at the menu, which we call now a status bar or action bar. And then we're going to add preferences where you can update your username and password server. So we're going to basically go from one screen app to a three-screen app, right? So basically, what we're going to look at first is how to glue these screens together. So this is where we are learning another concept that is sort of unique to Android, and it's something called intents. And basically what intents are sort of events or messages. They're very lightweight, and they're a way to glue together these loosely coupled building blocks, right? So I'll give you an example. Let's say I'm reading, I'm looking at my Gmail application, right? So this is my Gmail app, and I'm looking at an activity, so a screen, a single screen, where I can see a list of my emails, right? So I see a whole bunch of emails, and then I want to see a particular email. So I click on that particular email. What happens next is I actually go to another screen, which now you know is an activity, and what I can see there, I can see the details of that email message, right? Who sent it and the text and so on. So what we did here is we basically fired off an intent, right? So we sent an intent to go from one type of activity to another. All along, we were still in the single app, right? Now, inside, I'm reading this email message, and it says, oh, check out this story about Android taking over the world or something. So I say, fine, I click on that, and what that does is actually launches a whole new other app. But inside of that whole new other app, it launches an activity, right? Because you can't see an app. You can see the screens inside of an app, okay? It's sort of like I use websites and web pages as an analogy. you can't see a website, right? You can't see CNN.com. You can see a homepage of CNN.com or a particular story on CNN.com, but you don't see a website. A website is just a container for a lot of web pages. So it's very similar sort of in Android. You don't see an app, you see a particular activity inside of that app, right? So we open up a web browser, and more specifically, we launch an activity that's now in that running stage, right? So it's visible, interacting with the user. So here I'm reading the story about Android taking over the world, and I got here because I clicked on yet another intent, fired off yet another intent. So what we're doing next is in this story, in this web story, I see there's a link to a video, so I click on that, and that may launch yet another application with yet another activity using yet another intent. So you kind of get an idea how we kind of flip-flopped across multiple apps, and the user is not concerned with that. Just like when you're surfing the web, you're not concerned you're going from a website to a website. You're just completing a task, right? So Android has the same concept of a task. And we can unroll or roll back by using the back button from this application stack. So that's what intents are. So they're basically gluing components together. They can be implicit, explicit. I'm going to talk about that in a second. But the point is, they can be within an app, or they could be across multiple applications, just like HTML links or HTTP links on the web, right? So, so basically, what can you do with an intent? I used an example where we just went from a screen to a screen to a screen, i.e. from an activity to activity. But this is not just limited to activities. You can do a handful of things with intents. You can start an activity, you can start or stop a service or bind to a service, or you can send a broadcast. So there are a couple of things you can do with these messages. Not all that many. So that's basically what intents do. Now, I briefly mentioned intents can be explicit, meaning I spell out how I want to handle a particular intent, or they can be implicit, meaning I let the system figure it out. So, for example, if I go back here, when I was in Gmail looking at a list of messages, and I said, all right, I want to see that particular message. This was explicit. It opened up that particular message using an internal message view activity of Gmail. There was no question about how to handle it. However, when I was here and I said, oh, I want to check out that story, that opened up a web browser, but which one? Well, we don't know, right? It could be that the user has the default web browser, it could be Firefox, it could be Chrome, it could be any number of web browsers that are available on the user's device. Just like when you downloaded your Safari or your Chrome or your Firefox, it asked you, would you like it to become your default browser? So it's a similar kind of resolution happening in Android OS as well with the implicit intents. So that's basically what implicit versus explicit intents are. And just from the implementation standpoint, for those of you who are familiar with Java, when we are doing explicit intents, we actually spell out the class that's going to handle them. So there's no questions about how we're going to handle this intent. Whereas when we are dealing with implicit intents, it's more of a action-based. An action is basically just a piece of text, right? Usually it looks like that, but it doesn't have to. It could be, Mickey.mouse or something. That's a valid action, right? So that's where the system gets to figure out what the best way to resolve it is. So the system resolves it using intent filters. I briefly mentioned them when we talked about what makes something a home activity or main activity, and that's basically an intent filter that says I want to know about that message that gets broadcasted. So somebody sends a message that says open up a web page, or somebody else is saying I'm capable of opening up a web page, and that's how Firefox competes with Chrome, competes with the default web browser, because they all raise their hand, and then the system says, all right, I got 3 apps or activities that can handle this. Which one would you like to handle it actually? So it works based on intent filters, and that's what an intent filter looks like programmatically. So we're basically saying just in XML, intent filter, action, and some name, Mickey Mouse could go here, and it'll be fine. So that's a little bit about intent filters. Now that we have intent filters, we can launch all these things, right? We can launch remember, we want to build 3 screens. So what we're going to do for that is we're going to use something called action bar. An action bar is actually something that's relatively new since Honeycomb, and it's basically this thing here. So it's basically this thing here. Well, it goes all the way. So it can have buttons. If the buttons can't fit, you can press on a menu and then more things would pop up and so forth. If you have a tablet with no menus, there's going to be a little dot, dot, dot you can click and it's going to expand and so on. But the action bar is sort of a more powerful, what used to be just a menu button on the older pre-tablet devices. So what we're going to look at is how to enable it. So basically, if you're using Android that's newer than Honeycomb, right? So any tablet-based Android, which is basically API level 11 or above, it's going to be pretty much automatic. If you're using older ones, it may look like the old menu. So they're very comparable. They just look different. But for the most part, they are very comparable in terms of how to implement them and how they work. There's some new features that we have in Action Bar that we're going to explore because we are mostly concerned with newer stuff anyhow. So basically, to create an Action Bar, again, it's very similar to building a UI. You do a little bit of XML, you specify what buttons you want, right? So this is what it looks like. This is like me saying, I should have a menu save button and show it if there's space with text. And if there isn't space, that's okay. Just put it behind the dot, dot, dot so the user can click on the dot, dot, dot and expand it. So it doesn't have to be all that complex. So that's what that would look like. In Ice Cream Sandwich, there's also a support for something called a split action bar. So basically, if you have a lot of buttons and you can't fit them on the top, like in this case I can, if you notice, in this case I can fit them all here, but in this case, if I rotate my screen on the emulator, so I'm going into a different view, I can't fit them there anymore, right? So what I could have done is I could have used the feature of Ice Cream Sandwich to have the menu button also show up at the bottom. I didn't. I chose to put it behind the usual menu button because this device has a hard menu button, and here you can click on, for example, preferences, and you can update username and password, that sort of thing. So that's a split action bar. You can also enable certain things to happen when you click on that little icon there. So for example, if you wanted to have this go to a home, you can click on that as opposed to having to click on the back button. You can also have it go one level up. So there's certain navigation things that are new in Ice Cream Sandwich that make it a little easier to use from the user standpoint. So far we have three screens. So we have this screen. There's nothing in it, so this is blank, right? But we have the menus. So we have this menu, and we can click on this, and we can actually type something, and it's going to show up on the website, as we saw earlier. And we also have this screen where we can go and update our username and password. So for example, I can go and I can say my username is Bob, for example. But we have a way to push tweets out, but we don't have a way to pull them down. And this is where services become very handy. So services are things that are basically running in a background. But I want you to be careful with that word background because it means different things to different people. It doesn't necessarily mean it's running on a background thread. It just means you can see it, all right, for now. So basically what we're doing here is we now have the action bar. And by the way, these blue lines, that's my way of saying it's an intent, right? So we're firing an intent to go to this screen, firing an intent to go to this screen, and also firing an intent to run this refresh service, which is going to go to the cloud and say, are there any new tweets? Sort of like what your POP3 email did to check your email, right? That's what we're sort of doing. We're going to a cloud, pulling down data. So that's basically what it's going to do. But we need to trigger it somehow. So what we're going to look at is how to do services. So services are, like I said, things that run in a background. They have a much simpler lifecycle than activity, and usually don't get just destroyed by the system as activities do. Remember, activities have that complex lifecycle. They just get wiped out when the system thinks it needs more memory. So good example to kind of understand a service would be a music player. So say I'm writing an application that's going to play say it's a Pandora app. So I'm going to basically pick a station, I'm going to listen to music, right? So I obviously need some kind of user interface. I need somewhere where I'm going to give it thumbs up, thumbs down, pick a station, that sort of thing. So I need UI. But I also don't want to own the playing of the music on that in that activity, because it could just get wiped out from the system at any point. So we don't want the music to abruptly stop playing. So what we do instead is we basically create a service, and our UI simply starts a service. It may go away, and that's not a big deal because the music is running. Now when the user comes back to that activity may get recreated from a stop state, but may actually get created from nothing, right? From scratch, which is fine. It's just going to take a little longer, but to a user, it's just going to work. So that's why a service is a useful tool to own background things that run. Now, like I said, by default services, basic services, actually run on the same thread as a UI thread, and you got to be really careful about that, because doing network stuff used to be just a really bad practice. Now it's simply illegal. You're not allowed to do that starting from Honeycomb, because it's going to make your user interface sluggish, and you don't control it. So if I don't have a network capability, I may be sitting there for 30, 60 seconds until it times out, right? So that's a really bad idea. You get ANRs, application not responding, and this is what the users give you 1 star, and you can't sell your app anymore. So you don't want that. So basically, we're going to be running it on a separate thread. So service lifecycle, like I said, it's much simpler. You basically say start service, and it goes through create start, then it's in a running state, and at some point you say destroy service, and it gets destroyed. I'm pointing out that you say it as opposed to the system controlling it, so it's much more under your control what happens in terms of that. So this is a life cycle. So when you click on a service start, it goes to on create on start. When you say just start and it's already running, it just goes to on start, so it doesn't need to recreate something that's already created. If you're stopping a service, it destroys it. If you, I'm going to talk about something called intent services, but intent services actually get started on a separate worker thread. So they just basically start, they do some work in the actual background thread, and then they dispose of themselves. So it's a very useful little helper type of service. So this is a typical template for a service. It's much simpler for those of you who are familiar with Java. So just like before with activities, you start by subclassing something from a system. So this is something that's given to you. And then you simply override a bunch of methods. And you typically want to override something like onCreate and so on, right? So that's basically what it looks like. So it could be, usually it could be a relatively simple implementation. I mentioned intent services, and what I like about them is that they solve that problem of not blocking the UI thread. So basically, anything that you put in the onHandle intent here automatically happens on a background thread, so it doesn't basically it doesn't make your UI sluggish. So it's a very useful little tool. But other than that, it looks very similar to a regular service. So these are standard service callbacks, so way fewer than activity. So you have on bind, on create. So I said this is the one you universally usually care about. On start command and on destroy. An intent service has pretty much the same callbacks. The only difference is as opposed to on start command, it's called on handle intent. So just one tiny little difference, and whatever you put into this happens on a separate thread. Just like activities, you need to register your service. So if you're registering it for an explicit intent, all you need to do is you need to just say one-liner. This is my service. I have a service with a name, some service. Right? Music player, for example. If you want to start it using an action, you need to create an intent filter with that action and give it some kind of name, right? So that's the only slight difference when you, depending on how you're starting it. So far we have the following. We have the main screen, right? We have a way to post to Twitter. We have a way to change our username and password. We have a way to pull the data from the cloud. So we know the data is being pulled because we can see the dump of the data right in the console, in the log. But we don't have a way to display it to a user. So what we're going to do next is we're going to keep the local copy of that data, because you don't want every single time to go to the cloud for the data. This is where it's different to program native applications versus web applications. I usually check my tweets when I'm in a subway or flying somewhere and so on. And you may not be able to connect to a cloud in that situation, at least not that cloud, right? So, so it's good to have sort of a local storage, sort of a local cache of your data, just like Gmail does and so on. So for that, we're going to use something called status provider or content providers. So content providers are basically a way to expose data outside of your application. So you might have noticed, I draw applications like these like sort of silos, right? And they're sandbox. So basically everything that's in one application is only visible within that one application. So nobody else can touch it. It's actually controlled by the Linux kernel, so it's pretty secure. Now, every once in a while you do want to expose some data outside. So content providers become a really nice way to basically provide that interface to the outside world. And it's very simple. It's insert, update, delete, and query. The only 4 things you can do with data, right? Usually content provider is backed by a database, but it doesn't have to be a database. It could actually, in itself, go out to a cloud and pull the data, right? It could be doing something else altogether. So it doesn't really matter how the data storage persistence is implemented. System uses this all the time. So for example, your contacts are stored in a contacts provider, and then you basically have another application that shows you your contacts, like an address book. Your media store is also an independent content provider. So for example, if I'm walking down a beach and I take a picture of my daughter, that's a camera app, right? But it's storing that picture now inside of a content provider so that I can use it in my Gmail and email it to my parents, or I can use it in Facebook and post it as a new update and so on, right? So basically, by using something like a media store, I can share that piece of content with the universe within my phone, right? So this is an example that I kind of mentioned earlier, a typical example. So basically, your address book is actually not a single app. It's 2 separate applications. You have one app that contains your user interface. So it's got an activity or a couple of activities, but it's got no data. If you look at your contacts, you're not going to find any people in there, right? Your address book. There's a separate application altogether, which you don't see, right? It's there, it's running, it's a content provider, it's a contacts content provider, and it actually owns all the data. It's got a database, and it's got all your people in there. And basically, so that's where that loose connection comes in. So basically, one app is contacting the other app and asking for data. And this provides for an easy way to remesh an Android device. This is something you can do on Android, you can't do on many other things. So for example, HTC is going to come up with a it has something called Sense UI, which is a sort of a much nicer experience of Android, right? So typical Android is all about apps, and HTC take is more about people. So it's not like I want to SMS Bob and email Bob, but it's more about Bob, right? So what that allows HTC is to basically create another address book, maybe a sexier version of an address book that also has an activity that can now tap into the same data source. So you basically have a single data source. You can have multiple address books, for example. And this is just one example. So that's where content providers become very useful. They're relatively simple conceptually. You only have 4 methods. You have insert, update, delete, and query. The 4 things you can do with data, CRUD, right? But the implementation is somewhat not so pleasant. And so I kind of just provided a very rough skeleton here, but I'll show you what the full implementation of Yamba Content Provider is, for example. But basically, you have a lot of those methods: insert, update, delete, and query, and they need to do certain things, provide the data in a proper way, and so on. And it's all based on URIs, so it can be kind of like loosely coupled and so on. So that's sort of that's where we get into Java interfaces. So that's why it's not as much fun. In this particular case. But those are the methods. So you still have the onCreate, the usual. You have something called getType, because your contacts app could be returning different types of data. You have insert, update, and delete, and query. So those are the 4 CRUD methods. So that's a content provider. To register it, it's just like activities, just like services, except there's something a little new, and that's something called authorities. So basically you need to specify an authority for that content provider so that it can be found. And typically it looks like that, the reverse of your domain name plus some kind of provider name. It's not that unlike activities and services that we talked about so far. Okay, so at this point, so up until now, we had everything except we didn't have a way to see the actual tweet. We had it, so remember, we pulled it via service, we put it inside of a provider, which may have it inside of a database, but that's not known to the rest of the system, right? So that's internal implementation at the system level. But we don't have a way to see, or the user doesn't have a way to see the data, nor the user can see the actual content here. So what we're going to talk about next is how to build this. And it looks like we're talking about UI, but it's actually not just UI. So this is where it gets a little interesting. So Android provides something called adapters and lists. So I may have a very large database of content, right? So for example, if you're like me, you may have, let's say it's your Gmail account, you may have 10,000 messages in here, right? In your data source on your device. But your screen, if this was Gmail, you can see maybe 1, 2, 3, maybe 10 different things, right? So what our challenge now is how do we glue a rather large data source to a rather small screen, right? And this is, again, I know some of you are developing using web frameworks and things like that. This is where the native application becomes a little smarter than a web application, right? Because it doesn't need to download all 10,000 email messages knowing that I can't possibly consume it. You may get the first 10, maybe 15. And then as you scroll, it's going to dynamically pull the data, build the UI, reuse the UI, and so on and so on. So basically, the adapters are what provides for that glue, for that ability to connect a rather large data set to a rather small view. And they do it very, very efficiently. Now, one thing that I wanted to mention here in terms of the implementation is something that is called fragments. It has nothing to do with fragmentation for those of you who heard that dirty word, right? It's basically a reusable user interface. So remember when we talked about activities, I said an activity takes an entire screen, right? Well, when they designed the little phones, that was fine because the screen is so small. So why would you not want to take an entire screen, right? When they came up with tablets, you actually had a little more real estate. So they figured, well, okay, so we got more space. How do we put multiple things onto that screen? Also, they figured, okay, so if I'm going to write an application, Yamba or something else, am I going to have a different app for a phone, or a different app for a tablet, or a different app for a TV, right? And you probably do not want to have a different app. So you probably want to have a single code, and you want it to look great on a phone with a tiny screen, on a tablet, on a TV, and anything in between, right? And keep in mind that we have, what, 500-600 officially certified Android devices out there on the market. So we're talking about many, many different combinations of screen sizes, density per inch, blah, 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 right? So fragments are basically a way to build reusable user interface. So for example, if I had a tablet, my screen may look like this. I may have an activity, but that activity actually may consist of two distinct fragments, right? So I have a fragment for timeline where I can see the list of my tweets, and I may have another fragment where I can see the actual details, right? Now, if I'm viewing the same app on a tiny screen, what I would do is I would just rearrange these reusable components, and they would basically look like this. So basically, I would have one activity that has just one fragment, so it's essentially just wrapping it, and another activity that's just wrapping this guy. And basically, you would have to click, and you would open up another screen. So it's a sort of a traditional experience, right? So that looked like this, right? So basically, here is this mode. So this is this mode, right, where I can see only the list, and then I have to click and open up another activity, right? So that looks like this, right? So I can click on hello from building 10, and voila, there's another activity with the actual details. Now I can click on back, and you can notice that it kind of flips over, right? It goes back one back on the stack. Now if I just rotate my screen to landscape mode, I kind of pretend that now I have more real estate, right? So that's how I designed it. So if I rotate it, it's gonna redesign itself to take advantage of the more space. It's gonna say, oh, okay, I see that, you know, we have more space. I'm gonna show things here, and that's my tweet there. Now its emulator is not the most responsive, but basically it shows up on the side. There we go. The actual details. So that's more of this design here. So basically, the majority of my UI is being reused between these two components. So fragments. So maybe a little too wordy, but fragments are basically these new reusable UI components. They always must live inside of an activity, but they do not have to have the actual UI. You can actually have fragments that don't display at all. They're actually useful for some background tasks. They have their own life cycle. They attach themselves to an activity. They disattach themselves and so on. So that's basically those are the implementation details that we have. Now, another thing that's also new to support the lists, fragments, adapters, and everything else that came out with Honeycomb, and now that we use extensively in Ice Cream Sandwich, is something called loaders. And loaders are there to basically help us with the fact that that loading data could take a while, because you don't know how big the data set is, and although you're loading just maybe 10 items, it may take a while to load it if it's over the network or some other something else like that. So basically, what loaders are is a way to load data asynchronously. So it's an implementation of an asynchronous mechanism where you say start loading. When you're done, call me back, and then I'll retrieve my data. So that's basically what it does. So it's not necessarily a separate thread, or it should typically it should be implemented in a separate thread, but it's more of an asynchronous implementation of that. Like I said, we have it since API level 11, which is basically Honeycomb. So that's when it appeared first. One thing that I wanted to mention about, hold on a second, about the availability of all these components. Like I keep mentioning all these new things like activities, fragments, loaders, and a couple of things like that are only available from Ice Cream Sandwich. There's actually a support for them that goes back to Cupcake, which is basically a very old version of Android. So you can do it via something called a support library. So you just need to throw in a jar into your application. So you can take advantage of the latest, greatest, even though your app may be designed to run even on the older devices. So that's a very good thing that they provide, the backwards compatibility, way backwards compatibility. All right, so we are now at part 6 of 7. So basically, what we have at this point is we have an activity that we can see all the tweets. We're using the fragment layer of reusable UI to see the list. We have details activity that shows the details fragments. Remember, this could be one activity if we have enough real estate, but that's not that important. And everything's working pretty well. One thing that I wanted to introduce here is the final fourth main building block, something called a broadcast receiver. And basically, the reason why we need it here is simply because a refresh service, although I have a button here to click and kick start it, so I can press this and it's going to go and it's going to pull the... this is live data, so I apologize. So everyone who's reading the book has the username and password is student password. So there are just a lot of people using that service. So just bear that in mind. So basically, what we don't have is we don't have a way to kickstart our refresh service. So the refresh service can be started by a human. But when you turn on your phone, do you kickstart your Facebook and Twitter and Gmail and all the other apps? You don't, right? You just like open it up and it's like, wow, my emails are there. I didn't have to start anything. It just ran, right? So broadcast receivers are pretty useful for that. And basically what they are is a way to send broadcasts and have something else catch it. What's catching the broadcast is a receiver. So let me give you an example of that. So basically, for those of you familiar with design patterns, it would be observable pattern or publish subscribe pattern. But basically, I may have a piece of dormant code, right? It's not running. Unlike a service, it's not actually cranking in the background. It's actually not in memory at all. It's just registered somewhere. So we basically register it with the system. And we say, this piece of code should be kick-started when something happens. And that something could be, for example, an SMS arrived, or the battery is running low, or network is not available. Network is available. System finished booting. Those sorts of things, right? Or it could be our own broadcast, like you got new tweet. Do something about that, right? So basically what the broadcast receiver does here is registers itself, and when that something happens, the system triggers it. It says, hey, that thing you cared about happened, run your code. So that's basically their implementation, their at least design. The implementation is actually very simple. It's probably the simplest. You, just like everything else, you extend a system inherited class, broadcast receiver, but you only have a single method. There's no on create, on start, on restart, on pause, on stop, on this. None of that. There's basically a single method that says on receive. So basically, code just gets woken up to do something. I mean, there is on create and so on, but you do not need to worry about that for the most part. So basically, you just implement whatever you want to do in this block, in this callback method. So that's a little bit of a Java. And when that something happens, this is just our proof that we indeed got that action. So we're seeing this in a log that we received that action. Like everything else, it's got callbacks, but the list is very, very short on receive. So registering a callback, registering a broadcast receiver is also done in Android manifest file, that main file that controls everything in your app. And basically, you need to specify intent filter, which we talked about before. So you basically say what kind of action you care about. And like I said, those actions, they're system actions like new SMS or battery running low, or it could be your own actions like you got a new Yamba tweet, right? So that could be another way of doing it. You can also register it programmatically, but this is a little bit more Java. So in this case, what I'm doing is I'm doing essentially the same things that I'm doing in XML, but I'm doing it programmatically. So I'm saying, hey, there's a new intent filter, register it, provide that action, unregister it when it's done, and so on. So it's just a little more verbose and more Java, but it's essentially doing the same thing. So the final seventh part of Yamba is going to be this part in top bottom right corner, where we're basically adding a app widget. And what an app widget is one of those little things that you put on the home screen that shows you what's going on, right? Like it could be the little weather widget, or you have a new voicemail widget, or one of those things that you have on the home screen. Or it could be just a clock, right? So what we're going to do here is we're going to implement it. And basically, app widgets are surprisingly, they're actually related to broadcast receivers. It doesn't appear that way, but they're basically little pieces of UI that live somewhere else in somebody else's process, and they get a notification that says, "Hey, there's something new for you to update." So they're basically just like broadcast receivers. You use a very similar way of declaring them. There's some other things that you need to specify in addition that you do not need to worry about with broadcast receivers, and that's what the default size is and what the default refresh rate is. So you know how certain widgets are just bigger or smaller. For those of you who own Android phones, you know that sometimes for the same app there are 40-some versions of the same widget, just different dimensions. So that's because that's what they specify. They specify various sizes. And this would be a refresh period. So basically what I'm saying is, look, I don't care more than every 10 seconds about new tweets, right? So that's basically what I'm doing. So that's basically what the code looks like. It's a little wordy, so I'm not gonna go into the details. But some of the usual suspects: we subclass something from the system, we implement on receive, and the new one that we do is on update. So just like a broadcast receiver, you have on receive, but unlike broadcast receiver, you have on update. So that's something that's thrown in there. And finally, that's what it looks like. So we basically have a little widget that shows up on the home screen that may say something like that. In this case, it's very, very simple. But basically, I could click on it, and presumably it would open up the app and show me the details of that app and so forth. Yeah. So that's basically all the 7 components that we have of Yamba. Thank you, guys.